All right, here we find ourselves in 1.4, and we're going to start using the definitions of the trig functions to relate everybody to one another. A lot of these things have been said already, but we formalize it. And it's because you can see those relationships in the XR, YR definitions. And so what we find is that there's some we call identities, reciprocal identities. That sine is the flip of cosecant. Cosecant is the flip of sine. Cosine is the flip of secant. Secant is the flip of cosine. Tangent is the flip of cotangent, and cotangent is the flip of tangent. Right? Things that we know. So if we look at example 1, they just want really quick ideas out of this. Tangent theta, find tangent theta given that cotangent theta is 4. No problem. If cotangent theta is 4, tangent theta is just the flip of it for 1/4, and we're finished. It's really important, I haven't mentioned it yet, that you just don't write tangent. Tangent by itself means nothing. Any trig function by itself, it must be operating on an angle. Secant, given that cosine theta is 2 over root 20. So secant theta, let me get the C in there a little bit better. Secant theta is going to be negative root 20 over 2. And then they want us to find sine theta given that cosecant theta is root 24 over 3. Well, no problem. Sine's going to be the flip of that. And it's typically sine that you find and then find the cosecant by flipping. But they're reversing on us because they can. Remember, this is 3 over root 24. I would highly suggest in terms of before you rationalize the denominator, simplify it, that is 2 root 6 underneath, and then you just need to hit top and bottom by root 6 like you did in any intermediate algebra class. And then we would reduce as much as we could and get root 6 over 4 coming out of there. So root 6 over 4 is the right answer for that number 10 that's there. So they're going to have us just play around with trig functions, but the important part is if you know the sine, cosine, tangent, then you know the other 3 because they're just flips like we did before. And so it's very, 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 very important that you know the signs in each one of the quadrants. And so the way that we're going to help you remember that is, let me make this a little bit bigger. We're going to remember that all students take calculus. So let me make that smaller now. All students take calculus. If you can remember that, it tells you what's positive. A means, and let me put it in a different color, all. Right? Every single trig function is positive in that quadrant. S means sine. So only sine theta and its flip, so who's its flip? Cosecant theta, would be positive in this quadrant. And here's the reason why. Remember what's happening here. This would have a positive x and a positive y. This would have a negative x and a positive y. So, and sine corresponds to y, so your y's are all positive, so it's the other ones that are going to be negative. So there's a very real reason why that's the case. T means, as you can imagine, tangent theta or its flip, cotangent theta, are the only ones positive. So it's not like we know those are positive and we have to figure out everybody else. Only tangent and cotangent. Let me make that look like a T, it look like an S. I'm going to go here and re-erase it. Only tangent and cotangent are positive in that quadrant. And here, only cosine and its flip secant are positive in this quadrant. And so that's what you have here. In quadrant 2 would be S, so sine and cosecant are positive. Third quadrant, T, all students take tangent and cotangent positive. Fourth quadrant, calculus, only cosine and secant are positive. So we want you to determine the signs of the trig functions with an angle in standard position. So 84 is a first quadrant angle, so all are positive. Negative 15 degrees is a fourth quadrant angle. So what would be, so let me make sure you understand that negative 15 degrees would be just underneath that side. You don't have to draw it perfectly, but that's going to be in the fourth quadrant. So remember, all students take calculus. It's only cosine. So sine of negative 15, they're not asking you to find it, is negative. Cosine of negative 15 degrees is positive. Tangent of negative 15 degrees is negative, right? Cosecant is negative. I should put the 15. Secant and is positive, right? Because it's in the fourth quadrant. And then cotangent of negative 15 degrees would also be negative, right? So apologize, there's not a huge amount of space there to write all that in. But you can know really well what you have. So how about 6 pi over 7? And this is where radians really, really work. 6 pi over 7, you should know right away that that guy is in quadrant 2, right? Or Q2 would be a better way for that to write. But we are absolutely in the second quadrant. Why? Because where is 6 pi over 7? Really close to 7 pi over 7, but not quite there. So everything can be related to the pi measurements, and we are right here. So who's positive in there? All students. So sine's positive, cosine's negative, tangent's negative, cosecant is positive, secant is negative, cotangent is negative. And you're finished. Where's 8 pi over 7? I did it again. Sorry about that. I have to kind of scroll through this. It'd be the fastest way. Where's 8 pi over 7? Oh, geez. Sorry for the comedic errors here. I got to be careful where I'm touching on the side there. Try to get rid of it in future endeavors. I'll be more careful right now. I wasn't as careful as I could have been there. 8 pi over 7, that's in quadrant 3. So who's positive in quadrant 3? Tangent and cotangent. So sine's negative, cosine's negative, tangent's positive. Cosecant is negative, secant is negative, and cotangent is positive, right? So identify what quadrant we're in. Tangent's positive. Okay, could be quadrant 1 or it could be quadrant 3, right? All students take. So all students take calculus. So it's either 1 or 3. Because cosecant is also not positive, it's got to be quadrant 3. And you're finished. Sine's positive. Okay, that could be 1 or 2. And cosecant's positive, but cosecant's the flip of that. And notice it says or possible quadrants. So this is 1 or 2. You wouldn't know because they use the flip of that. With this other one, we absolutely knew because they chose a different one. Cosine's negative and sine's negative. Well, sine's negative in quadrant 3 and in quadrant 4. And cosine's negative just in quadrant 3. So it's quadrant 3 in there. And so quadrant 3, 1 or 2, and quadrant 3. And we're just running through the all students take calculus. It can't be this one because they're all positive. It can't be this one because sine's positive. It can't be this one because cosine's positive. It's got to be quadrant 3 where sine and cosine are both negative. And that's what's making the positive tangent, right? When you have a negative y and a negative x, it's making that into the different ones. So here's what we find. Let's talk about the range. And so I think they gave me one less box than what I need. So I'm going to do both in the same. So sine theta. Sine theta as a function, right? Let's talk about its domain. Its domain is all reals, negative infinity to infinity. You can take the domain, you can take the sine of anything, but its range, and what you're going to find is that it goes from -1 to 1. You will never get any higher value out than -1 or 1 in that regard. Now, as we go to cosine of theta, I'll do that here. You can take the cosine of anything. So its domain is also all reals. I guess these should be open parentheses, right, to be technical. -infinity to infinity. And what's the range of cosine? The highest value the lowest value you can get is -1. The highest is 1. And so it's very much like sine. Now tangent. Remember what tangent was. Tangent theta is y over x. Well, it's going to have a problem whenever x is 0. So where is x 0? Here at pi over 2. Okay, and also at 3 pi over 2. So the domain of tangent is the set of all x's such that x does not equal 2n plus 1 pi over 2. I need to make sure that there are an odd number of pi's. And n can be any integer in there. So you're not allowed to plug in pi over 2 to the tangent function because it's going to be undefined. The range, though, what you'll find is as you get, you know from, maybe you don't know, you'll learn in this class that by these points where you're undefined, you really get shoot up to infinity. So the range is actually all reals. -infinity to infinity can be reached through the tangent. And then if we quickly talk about the flips, the cosecant of theta, the flip of sine, actually maybe I can come back up here. The cosecant of theta, now this isn't the inverse function, right? This is its reciprocal function. The domain is all reals except you got to take out any time that the sine is 0. So anytime it's n pi, we're going to have problems. And the range is from, it's interesting, it's -infinity to -1, union 1 to infinity. Because this range is between -1 and 1, they're true fractions, when you flip them, you get really big numbers, or both positive or negative. And so and then you could get as low as 1 or -1. Secant theta, its domain is very much like tangent, the set of all real numbers, except we can't have any of the odd number pios over 2. Those have got to go away, the 90 degrees and all of that. Its range is from -infinity to -1, union 1 to infinity, right? That for the same reason. And then I'll do cotangent down here. Cotangent theta as a function. Domain. Now you can't plug in everything you want, because what does cotangent have on the bottom? It has the y's. When are y's 0? Anytime we're a multiple of pi. So you can't have any of those. And its range is from -infinity to -1, union 1 to infinity. And I apologize, those 1's are included. We can achieve that value of 1 like you've seen. So those should be included in there. And I wasn't including them, but they do come in touch right at that 1. So you'll see these in graph form as we go along. But here they are. Here is the ranges. They didn't really talk about the domains, but I just thought we could for a moment. So sine and cosine, you have to have a value between -1 and 1. Tangent and cotangent will spit out any value that you can dream up. Secant and cosecant can spit out any value except true fractions, numbers between -1 and 1. And so how about the cotangent being -0.9999? Sure, that's possible, because cotangent can be anything. Cosine is bound between -1 and 1, so this is not possible. Cosecant being 0? Cosecants have to, there's no way it could be 0 because they are 1 over the sine and therefore have no chance to have a 0 up top. So this is no, not possible. Sine theta equal -pi/8. Well, I got to know that number. Well, that's 3.14 divided by 8. That's definitely a number less than 1. So this is a yes. Okay, that could totally come out. This is a very common problem to have in a homework exercise set, and it's really, really nice. So suppose theta is in quadrant 3 and tangent theta is equal to 8/5. Find the values of the other 5 trig functions. This will usually make the cut for exams. In fact, almost always. I'd be shocked if it wasn't. We're definitely in quadrant 3, and what we know is our tangent, which is y over x, 8 over 5, is 8/5, right? So that's why I'm putting the 8 and the 5 where they are. Now, the wise student will put the signs in there. Notice we're 5 to the left and 8 to the left. The fact that we're getting a positive tangent is because of a negative divided by a negative. So we have to take some time to figure out what r is. R is equal to the square root of 25 plus 64, which is the square root of 89. Well, that's not a perfect square. I don't even think it can be broken down at all, so that's what we're left with. You cannot expect your r's to always be pretty. So what's the sign of theta? No problem. Y, or opposite, over hypotenuse. And then remember to rationalize. What's the cosine? -5 over root 89, or -5 root 89 over 89. What's the tangent? Well, we know the tangent. It was 8/5, so I'm not going to write that. It said the other 5. So what's the cosecant? The flip of sine? That is root 89 over 8, but negative. What's the secant, or the flip of cosine? Well, that's negative root 89 over 5. And what's the cotangent? That's positive 5/8, right? The flip of that guy. That quickly we can do that, knowing our I was going to say Pythagorean relationships, so that's not the right word. Knowing the reciprocal relationships that are there. And it's kind of showing you something in the process, and that is our angle is probably like this, but we're able to utilize this angle. If two angles have the same terminal side, you could use either one to determine the sine and the cosine, and we'll use that to our advantage in a little bit. Pythagorean identities. Sine squared plus cosine squared is equal to 1. And it'd like me to derive them. So let's take a look at something. Let's just look at any old angle theta here. I'll put it in the first quadrant for ease. Let this point be xy. So this is x, and this is x, and this is y, and this is r. So what do we know? We know x squared plus y squared is equal to r squared. So that's the reason why they're called the Pythagorean identities, is because they come from the Pythagorean formula. Here's what I want you to do. I want you to do something very specific, but remember, you can do anything you want provided you do the same thing to every term. And so here's what I want. I want to divide everything by r squared. Now, why would I do that? Well, that's because I would have this as a result. X over r squared plus y over r squared is equal to r squared over r squared, or 1. Well, what's x over r squared? Cosine squared theta. What's y over r squared? Sine squared theta. And then we have a 1. So if you move it around and put the sine squared first, sine squared theta plus cosine squared theta is always equal to 1. And they call that the Pythagorean identity. The other ones can be derived just from that guy right there. So if you want to know how the other ones are, just remember what tangent is. Let me come back up here. Ooh, maybe too far. This guy right here. Oh, they don't have it written just yet for you. Thought they did. But we could derive them all that way by knowing what we wanted. So if we started out with x squared plus y squared equals r squared, and what I could do is say, hey, I want to get the tangent squared. Well, if I'm going to get tangent squared, that's y over x. So I'm going to choose, and I'll put it in red here, to put an x squared under here. I'm going to put an x squared here, and I'm going to put an x squared here. Apologize, I'm just going to keep it the same way. I was going to use a relationship that they haven't shown you yet. So what is this? This is 1 plus y over x squared is equal to r over x squared. Whoops. And let me put that squared on the outside. So what is y over x? Y over x is cotangent. Oh, no, it's not. Apologize. Y over x is tangent. Squared theta. R over x, well, that's the flip of cosine. So this is secant squared x, and you have that second relationship right there. And equivalently, you could do the third as well. I typically just memorize the first one. I can easily memorize sine squared plus cosine squared equals 1. This is the relationship that I was looking for, that sine or tangent is sine over cosine, and cotangent is cosine over sine. We could easily derive them in the same way, but that would have allowed me to handle those identities a little bit differently. So here's what they like us to do in number 6, or exercise 6. They'd like us to find cosine and tangent given that sine theta is negative root 2 over 3. And cosine theta is positive. So the sine's negative, but the cosine is positive. Okay, all students take calculus. Cosine's positive, but sine's negative. Got to be right here in quadrant 4. Okay, so it's a fourth quadrant angle. That will help me. And they want me to find cosine and tangent in that process. They're asking us to use an identity. You can, but you don't have to. But let's suppose that, let's use the identity. Let's do what they're asking us. So let's use sine squared theta plus cosine squared theta is equal to 1. We'll try that one first. We're given sine theta, that's negative root 2 over 3, and we're going to square it, plus cosine squared theta, that's what we're looking for, is equal to 1. So if I square this, I'm going to get 4 ninths, oh, not 4 ninths, apologize. I'm going to get 2 ninths, right? Negative times negative is a positive. Root 2 times root 2 is 2. 3 times 3 is 9. Plus cosine squared theta is equal to 1. So that means cosine squared theta is equal to 7 ninths. Right? Because it would have been 9 ninths minus 2 ninths for 7 ninths. So what's cosine theta equal to? Technically, it's plus or minus root 7 over 3. And we know, though, that since we're in quadrant 4, that, and I'll come in here with a red pen, that it's not negative. It's the positive. So we used our identity, like they asked, to find out that the cosine of theta is root 7 over 3. Now that we know the cosine of theta, let's come in here and figure out the tangent. And they say to use identity, so let's do that. What do you know the tangent theta is? Tangent theta is sine theta divided by cosine theta. That's mentioned above here. But remember, sines y, cosines x, so that makes a whole lot of sense that it was y over x. Now, what's sine theta? Sine theta is negative root 2 over 3. And we need to divide that by cosine theta, which is positive, root 7 over 3. And so if I divide, what I get is negative root 2 over root 7, or negative root 14 over 7. And that's how we're going to get our tangent. And so they're asking us to do it that way as we go through and do that. They wanted us to use identities. It doesn't have to be the case. I could model these other ones not using identities at all, these last two that are here as examples. So if we were in class together, I could turn some time over to you to give it a shot. But since we're not, I'll just fill in here. So here we have cotangent theta is equal to negative 7 over 24. And so one way to do this, they're asking for the sine and cosine, is actually to draw the angle. So they're saying the angle is in quadrant 2 and that it's cotangent, and cotangent is the flip of tangent. So cotangent is x over y. So I'm just representing a triangle in here. I don't have to draw it to scale or anything, but I did put a negative on the 7 because that's the negative x direction. The 24 is positive. That will help me get the signs right. So as we go do the sine of theta, I'm almost done. I know that it's y, or 24, but I don't know what it's over. So sine of theta is opposite over hypotenuse. And so I got to figure out what r is. R is the square root of 49, right? 7 squared plus 24 squared. Right? And if I plug that into my calculator, I get the square root of 625, which is equal to 25. So sine theta is 24/25. Just found out that that was 25. Cosine theta, well, that's adjacent, negative 7, all over the same hypotenuse, 25. Now you want to stop and say, do my answers make sense? Well, let's look. I'm claiming that sine's positive. Would that be true for a second quadrant angle? All students, yes, it is. I'm claiming that cosine's negative. Is that true for a second quadrant angle? Yes, because only sine and cosecant are positive in that quadrant. And we're done. They just wanted those two. And you can see that these are tied into the book. This is number 74. Find the remaining 5 trig function values if cosecant theta is 2. All right, let's go do that. And we're in quadrant 2. So pretty much the same picture. I just used the same one. Cosecant is the flip of sine, so it's y over r is sine. So this is r over y. So the r is 2 and the y is 1. It's good. And then I got to figure out this other side. We know how to do that. 1 squared plus this x I want to figure out squared is equal to 2 squared. Or x squared is equal to 3. And so apologize for that. I touched over to the side again. So x technically is equal to plus or minus root 3, but you know that it's the negative one this time. It's the negative guy because we're headed in the negative x direction. And so it's awesome. You're going to be thinking about the problems, picking the right signs, and then to find the remaining trig functions, you just do it. Sine theta, y over r, or opposite over hypotenuse. Cosine theta, adjacent over hypotenuse, or x over r. Tangent theta, opposite over adjacent. Okay. Cosecant we already knew was 2. Secant theta, negative 2 root 3 over 3 if I rationalize it. And cotangent theta, negative root 3. Bringing that root 3 to the top that's there. And that quickly you can get all those sines and cosines and tangents. So this is an exercise, these sections that you've done, they are all about you getting familiar with these trig functions. So have fun with it. Let me know what questions arise.